Hello everyone, welcome back to the channel. Today we are going to continue from question number 15th of integration chapter exercise 7.3. The previous questions are in the other videos. You will find the link in the description below. Now if you are interested in these questions, grab your book and pen and let's begin. So over here we want to integrate tan cube 2x into sec 2x. Now, you can substitute tan 2x as t. If we substitute this, then we will have sec square 2x into 2. But now, we do not have sec square 2x here. So, this substitution will not work. So, what else can we substitute? We can substitute sec 2x. So, look for sec 2x. So, we will substitute sec 2x as t. So, when we are doing integration, you have to think that if like here you have two functions, which of the two functions would you like to substitute? You should substitute such a function whose derivative is there in the question. That's most of the time that is how it works. Okay. So, now that we have substituted sec 2x as t, its derivative is sec into tan and 2x derivative is 2. So, that is why we will need sec 2x into tan 2x. Let's split this up as tan square into one more tan over here. Out of the tan cube, we have written square and one term over here. Okay. So, we have the derivative here, but our substitution is not tan, it is sec. So, let's write tan as sec square minus 1. Okay, that is the identity we know. So, from here sec into tan dx is dt by 2. So, this term is dt by 2 and this term sec square will become t square. So, now you have the function. Now, you can integrate it. Half which is constant, let us put it outside. Integration of t is t cube by 3 and integration of 1 is t. Substitute back our t value which is sec. So, sec cube 2x upon 3 and sec 2x upon 3 and sec 2x. Okay. And of course, you can multiply that half inside. Integration constant plus c as usual will be there. Now, to integrate this 10 raised to 4, let's split this up as tan square x into tan square x. So, that one of the tan square x can be written as tan square x into sec square x minus 1. Further, so this part is sorted. Now, if we put tan x is t, sec square x dx is dt. So, this is done. For this one further we can write, so let us write this as tan square x into sec square x dx and the other one is sec square x minus 1. We know we cannot integrate tan square x directly, we have to apply the formula and then integrate it. So, this integration will be possible. Let us go to this one, let us call this as I1 and the other one is I2. Let us solve this separately. So, the integration of the first one, that is tan square x into sec square x. In this, because we have the function and its derivative, we will have to go with the substitution. And so, we have tan x as t, sec square as dt. Substitute here, it becomes t square because we have here tan square x. Integration of t square is quite simple because we are going to integrate two different integration functions. We will call it C1 over here. And what is t? Tan. So, we have tan cube x upon 3. That is the first one. The second one is quite simple because it is a direct integration formula. Integration of sec square is tan x and integration of 1 is x. So when we put both of this here, we have integration I is tan cube x upon 3. Now we have a minus sign here, so all the signs will change. Tan x minus of minus will become plus x, and now C1 and C2 combine together. That is, what is C here? C1 minus C2. That's what we have written. So we will combine the integration constant. For this question, we have sin cube x plus cos cube x upon sin square x into cos square x. So this is quite a simple question. We can simply separate these terms out. Let's separate and see. Whenever you have one term in the denominator, you can think of this. We are considering this to be one term because it is sin square x into cos square x, not plus down there. Okay, so you can see that sin square x and sin square x from numerator. Over here also this will get cancelled. So we have sin x upon cos square x, which can be written as tan x into sec x. And this one, cos upon sin square, cot x into cosec x. Now these are directly integrable. Tan x into sec x is sec x, and cot x into cosec x is minus cosec x. A very simple question. This is cos 2x plus 2 sin square x upon cos square x. So as we know, we want same angle in the question for easy integration. So we can easily convert cos 2x. What are the different formulas of cos 2x? One is 2 cos square x minus 1, another is 1 minus 2 sin square x, and there are other formulas, but we are writing the ones which we can substitute over here. Since we have 2 sin square x, we will substitute 1 minus 2 sin square x. You can substitute any formula. Finally, on simplification, you will get the same thing. But this one will bring you to the result faster. Because see this term got cancelled. 1 upon cos square is sec square x. And what is integration of sec square x? Tan x. One of the most important thing about integration is to know the formulas very well. If you know the formulas very well, it becomes easier. Now since we have 1 here, we can write it as sin square x plus cos square x. Now like one of the previous question, you have only one term in the denominator. Only one term once again because it is product. You can separate this out. So we'll write this as sin square x upon sin x into cos cube x, and the next one also in the same way. On simplifying or cancelling out the terms, what do we have? We have sin by one of this cos, which is 10, and after that also there is cos square x, when 1 upon cos square x is sec square x. Over here cos square x will get cancelled. Now we once again have 1 upon sin x cos x. So this one again we will write as sin square x plus cos square x. So that once again we can separate this and get an integrable function. So tan x into sec square x, we know this is the function, this is the derivative. So once again we will have to say let tan x is equal to t, and so we have sec square x as dt. So this becomes t dt. Tan x is t and sec square x is dt. In this one, the second part, when you separate this, sin square x upon sin x cos x plus cos square x upon sin x cos x. Cancel the terms. Now we have sin by cos, which is tan, and cos by sin, which is cot. So we have this integration, first one, which is t square by 2, let's say C1. We have sine by cos, which is tan x, and cos by sine, which is cot x. So t square by 2 plus C1, integration of tan x is log modulus sec x, and integration of cot is log modulus sin x. And because it is a separate another integration, we will call it C1, C2, and then we will combine both of this. Put t value back. That substitution was tan. So that is our integration now. So once again we are with cos 2x and x as the other angle. So we will substitute cos 2x over here as cos square x minus sin square x. Since in the denominator we have cos x plus sin x, both the functions, that's why. So this becomes cos square x minus sin square x, and denominator is cos x plus sin x whole square. So as soon as we write this, we know we are going to apply a square minus b square formula, which is a minus b into a plus b. And so one of the term from the denominator will get cancelled. Now we are left with cos x minus sin x upon cos x plus sin x. So let's think of substituting the denominator as t, and over here the derivative is nothing but the numerator. So it is cos x minus sin x dx, which is dt, and denominator is t, integration of which is log modulus t. Put back the value of t. Now because we have cos x here and sine inverse, we will convert cos x as sine of pi by 2 minus x, because we know that sine inverse of sine will get nullified and we have pi by 2 minus x. Integration of pi by 2 is pi by 2x, and integration of x is x square by 2. So if you can just think of like converting this, it becomes very easy. So that completes with the set of questions today. Question number 22 along with the extra questions of the same kind we'll be taking up in the next video. See you soon.